you subtract, you get 10 over 5x. You got to be careful. A lot of people are still giving me, at this level, people are still telling me the answer to this is not 2 over x. They're telling me it's 2x. That x has to stay in the denominator as opposed to moving it up to the numerator. That's still a common error at the Algebra 2 level. Again, down the page, no equals. Key component here, you have to have the common denominators. Obviously, this isn't the problem that we're so concerned with. It's when they're not common denominators and you have algebraic expressions. When we add, what do we get on the top? 2 plus x. I would probably write x plus 2, just to have it in descending order. It's just what we've been doing all along. If you wrote 2 plus x, not the end of the world. Can I reduce?
No.
Why not?
Because there's no anything in common plus.
There's nothing in common here. We have plus signs, and this is nothing in common, and there's no x plus 2 in the denominator. Jane, can we reduce these? Sure. What about the x and the x? They can cancel. That was a different Jane?
What?
Huh? Yesterday Jane was doing that. Do you remember?
Tell me
Do you want me to touch this?
I have a device for turning that off.
It's like Verizon, and I have no GPS, so I don't know why they call me.
Getro?
You know what I don't know? Why it's on. Alright, so now when we're adding and subtracting, we don't have common denominators. You've got to get a common denominator. What's the only thing you can do to a number that doesn't change its value? Well, actually, there's a couple. Multiply by 1.
Divide by
Or divide by 1. What else could you do?
add 0.
Add or subtract 0. So we're going to go with multiplying by 1 when we change these. Now, these problems are in your homework, and what you need to realize is that these are denominators. So this is really the denominator, and this is the denominator, and they're asking you to find the least common. What wasn't you? Was there? Seriously? So least common multiple is the same as finding a least common denominator. First thing you need to do is factor. So when we factor here, you're going to have 5, x squared minus 9, 5x plus 3, and x minus 3. Here when you factor, you're going to pull out a 4. And you get an x plus 2. Sorry about that. X plus 3 squared. Now, when you find the LCM in this case, or an LCD in general, you need to make sure every factor from every denominator appears, and it has to appear to the highest power available. So that means we have to have a 5, we have to have an x plus 3, an x minus 3, and a 4. So we can probably put that 4 in the front here. You have to have 5s, 4s, x plus 3s, and x minus 3s. Now the only factor that repeats between the two terms is what? Which one has the higher power? X plus 3 squared. So we want the square to be equal. So your LCM is going to be 20 x plus 3 squared and x minus 3. Your LCM or your LCDs have to have every factor to the highest power available.
Is that one?
It is 5 times 4. Yes, sir?
So, to find that, it's pretty much combining the factors of the two denominators.
Well, it's really factoring this one, and then choosing every factor, and if they repeat, to the highest power available.
Okay, okay.
So you're just saying, what do they have
But then,
here, what do they have here, and are there any repeats? Then we'll take an x plus 3 to the higher of the two powers. Now, if there's numbers, you know, if you had a 10 here, you got to be careful because 5 goes into 10. So with numbers, it gets a little bit different, but you just have to be paying attention for your LCM. You did this in 6th grade, 7th grade. You did it when you added and subtracted fractions then. No different, except now you have variable expressions.
I have a question. So there's x plus
Why do
3
you want
times 2. There's x plus 3, there's 3 of them. Why do you only have
No, hang on. Remember, don't think about it as this is an x plus 3 times x plus 3 and another x plus 3. Think about this is an x plus 3. This is an x plus 3, but it's raised to the power of 2. When you divide into your LCM in this case, or an LCD, both of these would divide evenly into this, right? That's why we don't, you can put an x plus 3 cubed, but it's not necessary. It's overkill. You only need the highest power available.
So if, in the other case, if it was x minus 3 squared, it would just be x plus 3 and then x minus 3 squared, just to the highest power.
You mean if this was a minus?
Yeah, that was
Then,
minus.
then this would be squared and that would not.
Yeah.
And it's also, it's equally true numerically. You know, if you have a 20 and you have a 36, you want to know what's the least common multiple, what's the smallest number they both go into. This is 2 squared times 5. This is 2 squared times 3 squared. Your LCM is going to have a 2 squared, a 3 squared, and a 5.
Okay.
Does that make sense?
Yeah.
So you only take what's common and you take it to the highest power. This was a tie. And then you got a 3 squared, you got a 5. You got to take every factor to whatever the highest power I can get for that factor.
So if there was squared on any of them, it would be 5 plus 3 other ones.
We're back here.
If there wasn't.
If this wasn't a squared, then this wouldn't be squared. The highest power between x plus 3 and x plus 3 would be x plus 3 to the first.
It's still 2x plus 3.
What's the highest power on the x plus 3? So if we erase that, what's the highest power? So when? You don't need to put it in twice. You can put it in twice, but then you're back to it's not the LCM. It's just a common multiple. Or it's a common denominator is really what we care about. We don't care so much about the multiples as we care about the denominators. Okay? Everybody okay with this example? Okay? Always looking for it to be in factored form to begin with. Try this one. So these are, if you want to think about them as denominators, you're really just finding the LCM for these. The first one is already factored, 4x squared. How does the second one factor?
4x.
So if you look at your LCM, what's it going to have? It's going to have 4x and 2x minus 3, right? That's each factor. Do any of them repeat?
Yeah, 4.
No, that's, you've said two things. Some of you are thinking 4x is one thing. It's not. So the x repeats. What else repeats?
4.
The 4 repeats. What's the highest power on the 4? 1. So we're going to keep it as a 4. How about on the x? 2. And the 2x minus 3 is a solo. So you have 4x squared times 2x minus 3 is your LCM. Does everyone see this? Back to 6th grade, 7th grade, right? We need common denominators. What's the common denominator? 20. So the way to handle this is we want to have two fractions being added together, both with common denominators of 20. So what you want to do is you want to multiply, if a fraction's not already at 20, this one's already at 20, so we'll go 9 here. This one's not a 20. So you're going to multiply the denominator by what to get to 20? 10. So we're going to do 10 times the 2. If you do it on the bottom, do it to the top, and you're going to get 70. What did we really do? We really multiplied by 1. When we add, what do we get? 79 over 20. Leave the answer 79 over 20 unless you can reduce it. Changing it to a mixed number is not reducing. 79 over 20 is fantastic.
Why do you say you multiply it by 1?
What's 10 divided by 10?
1.
That's why I said I multiplied by 1. Good idea. You think I would just lie to you like that?
No, seriously, we have to multiply by 10.
Yeah. Everybody good with that? You see it, right? What's the common denominator with variables now? 4x. Easy peasy when it's like this. What did you do to 4x to get to this denominator? Nothing. So don't do anything to the top. What do we do to this? Do the same on the top. Bless you. And when you add, no equals, straight down the page. Okay? The issue again isn't going to be so much with monomial factors. You guys will do great with those. It's when you have the binomials and trinomials in the denominators that become a little bit of a pain. Now, one of the things that you can do to help yourself, and this is how it would appear typically in a test, a quiz, or in a homework, or in a worksheet. When you have a denominator or a numerator that's a polynomial, you may want to go right ahead and just put parentheses on it. So you remember that it's not an x and a 3, it's an x minus 3 as one entity. So the LCD, when I write my two fractions, what is the LCD going to be? 5 and an x minus 3. What do we have to do to this denominator to get the LCD? By 5. So we're doing top and bottom again by 5s. So you're going to have 35, and we don't do anything here. So when you subtract, what do we get? 26 over 5 times x minus 3. Leave your denominator factor. Do not multiply the 5 into this, bless you, minus 3. Everybody, I feel like I'm going fast, but if you're not following, I want to go back before we go to the next ones. So now, we don't have what we want, right? The right-hand fraction, the one over here, is not in factored form. You need to make sure your denominators are factored, and to be honest with you should make sure your numerators are typically factored also in case you can reduce. The 3 over 10x squared and the 2x over 5x times x minus 2. Now, some of you, as soon as you walk in this room, you put your t-shirt on. You need to stop doing that for these problems. Yes, I know it's going to take an extra 2.3 seconds to write that line, as opposed to the lazy student who is just going to do this. I can just do it this way, Mr. Lockley, because I'm so smart, I can do it. Don't show the process. When you don't show the process, I assure you your partial credit will be virtually non-existent. All I did was factor the denominator. And again, I know this is a pain. You have to rewrite the whole problem just for one denominator. Do it. What's the LCD going to be now? X minus 2. So again, now we're starting to mix them in, and you've got to say, with the numbers 10 and 5, if you need to factor the 10 to 2 times 5 times x squared, some people will do that. I'm not going to do that. But if it helps you, then you'd have a 2, a 5, then you have an x here and an x here. We take the x to the higher power, which is squared, and we have to have the x minus 2 factor also. I can show you something different if you're not seeing that LCD. The 5x didn't go away. So, Jane, in the LCD, you have to have a 2, right? You have that look now. Right here. Oh, 10 is 2 times 5? Right? All I did was write it more factored for you. Because you have to have every factor to the highest power available. So here's my two denominators. I have to have a 2. I have to have a 5. I have to have an x. Already said 5. Already said x. And I need an x minus 2. Okay, do you follow me? And the only one that repeats is the x. Oh, sorry, and the 5. Why? Here's my denominator.
I get that part. And on the right side,
This is the same. I haven't done anything to the red. Fraction plus fraction in factored form. To choose my LCD, I need to have 2's, 5's, x's, and x minus 2's. The 2 is to the first power. The 5 is to the first power. 2 times 5 is 10. X squared or x, we'll take x squared. And x minus 2. So 10x squared, x minus 2 is my LCD. Listen, Jane, if you have 3 over 10 plus 2 over 5, what's the LCD? And you know it instantly, right? You don't need the red line. You have a 10, you have a 5. What's the LCD? Going to be 10. You already are really good at that. Don't abandon what you're good at.
okay.
Then you go to your variables. I got an x squared and x, I'll take the x squared. Got an x minus 2, x minus 2. I'm good at that. Good. So red is optional, not necessary for me at all. Now, what did you do to 10x squared to get 10x squared times x minus 2? Multiply by x minus 2. So we're going to do 3 times x minus 2. What did we do to 5x times x minus 2 to get to 10x squared times x minus 2? 2x, so we're going to have 4x squared on the top. Now if it helps you, and again, this is up to you, you could write times 2x times 2x like that. Bless you. If that makes it easier for you to do, and over here, you would be timesing by x minus 2 and x minus 2. If you want to show that stuff, fantastic. Know what you need to do. Everybody's different. And somebody may need to show me everything in red, everything in green. They may need to show all these things. And that's fine. It's going to take you a little bit longer, but not a lot longer. And if it eliminates mistakes, what are you thinking about by skipping those things? So now, when we combine on the top, we're going to have 3x minus 6 plus 4x squared over 10x squared times x minus 2. I'm sorry? How did I get the green? Well, I didn't factor it out because this was already factored. I did. I distributed to get rid of the parentheses and then added the 4x squared over the LCD. The denominator doesn't change. Somebody, come on. Anybody, help me out here. Yes, why do we do that? It's what we do. Why do we do this? It's not, I don't think it's any, it is descending order, so it's a standardized form, but why is that a good thing for us? So you can what? Factor. Because if you're not in descending order, it's hard to factor this mess. And if this is factorable, and you can cross-cancel after you factor, you need to do that. Is this factorable? Are there factors of 24 that subtract to 3? No. So it's not factorable, so you're done. But if you don't write it in descending order on the top, you're not going to know that. And you're going to get caught. Then you would cross cancel. Exactly. Now remember, these are all expressions, and expressions are going to behave different than equations. When we get to equations, you're going to have some limitations on solving those. You already know what the limitations are, but we don't need to talk about them today. Anybody have any questions on this problem? Top to bottom? Don't abandon your basics. Sometimes we forget the basics when we get to these complicated type problems. Give this one a try. See how you handle this one. You have an 8 as part of your denominator in the answer. You have a mistake. It's not an LCD, it's a CD. The one on the left is good to go. What do we do with the denominator on the right? Factor out a 2x. And you'd have left x plus 2. Right? So now that you're factored, you can go through and say, okay, my LCD, if you just look at the numbers, this is the example that Jane and I were just doing on the last one, just look at the numbers. What's the smallest number they both go into? 4. So we only need a 4. You don't need an 8. The next 2 times 4 is 8. Right? That's how people are going to write what goes here. They're not going to see this 4 as something that 2 goes into. They're going to write 4 times 2 and they're going to put an 8 here. Because they're different. When in fact 2 goes into the 4. Next factor is x. Which power should I take? Squared. And then the last factor is x plus 2. So we have 4x squared and x plus 2. What do we have to multiply the one on the left by? X plus 2. The one on the right, 2x. Does everybody follow that? So now when you combine them, you have 5x plus 10 plus 2x squared plus 2x all over your LCD. When you combine like terms and descend the order, looks like that.
Can you skip the step before that one? Like the 5x plus 10 plus 2x.
This one? Personally, I can't. I will bet dollars to donuts. The level of error will, because you're going to have to multiply these, and combine them all in your head. You're having a fantasy right now. You're trying to save time. Again, the T-shirt is all the way on. Don't worry about saving the time.
Well, I multiplied them out first, and then I just skipped that step there. So I should
Skip
do-
what step where?
Well, I have the two separate options on top multiplied out. And
I
then,
mean, you don't have this?
Like she has 5x plus 10 instead of 5x
yeah, well, I
plus
have
2.
that one, and then I have plus.
She wrote the whole fraction out.
Yeah, but then I just.
Okay, hang on. Let me see if I can get her to tell me what she has. Do you have this line written down? But not this line. Your next line says,
5x plus 10 over 4x squared times x plus 2 plus 2x squared.
perfect.
So that's fine.
That's fine. It's when you try to go from here to here that you're going to have problems. Now, you didn't have this step, but you did distribute. That's the step you're going to need to show.
Can't you factor?
I don't know. Can you? Did you factor it?
I didn't know I didn't factor.
Okay, so then my question to you is, can you factor it? I don't see it.
Aren't you go from the first top blue step to the next step?
Mhm.
Or do you go there?
How do they get from there to there?
The first option first.
From here to here?
Yeah.
Okay, well, from here to here, I factored this right here. What's the LCD? I want to know if you can find the LCD. It is 4x squared x plus 2. Do you get how that came to be? If we eliminate this, what do you do to 4x squared to turn it into the LCD? So what you should do, Jane, is show that that's what you're doing. So on the top, you're going to get 5 times x plus 2. What do you do to this to get to here? No. This denominator times this by 2x top and bottom. So 2x times x plus 1 on the top, and the LCD is on the bottom. And if that helps you, you should be doing that. A third of you are going to struggle mightily with the stuff in this section here on out. And you're going to struggle because you are trying to save paper and lead and ink instead of showing more work. If you show more, you will not struggle, but it will take you longer. And you can say that's not fair. What do you want me to say? If you can, some people can do this stuff in their head. What's not fair is that I make them show all their work. That's not fair. But that's the way it is. Bless you. Okay? Let's try this one. How does the left one factor? Yeah, and you want to write it as x plus 3 squared, not x plus 3 times x plus 3. How's the right one factor? X plus 3 and x minus 3, difference of 2 squares. Fantastic. That means your LCD has to have x plus 3's and x minus 3's in it. Which one repeats? So the x plus 3 repeats, that means we take the higher power, which is squared. There's your LCD. Is anyone not seeing how to get the LCD? Everybody feel okay with that? So now we go back to the what did you do? What did you do to x plus 3 squared to make it look like this? By x minus 3, and we're going to do that top and bottom. On the bottom, we get the LCD. On the top, you get x plus 1 times x minus 3. What do we multiply x plus 3, x minus 3 by to get the LCD? X plus 3, top and bottom. So we have 6, x plus 3. Now, every year I have a student who does this, and I've done it. They do this. They say, well, yeah, but Mr. Lockrey, these cross no, not that. Not that. This cross cancels with that, and these guys cross cancel, so you get this, right? Isn't that true? No, actually not. It's true, but you're now in a loop. You're trying to add fractions. You've got common denominators. You reduced, which brought you right back to what you had before, and now we need common denominators again. You don't cross cancel. The reason why we got this mess is so that they have the same denominators. So don't cross those out. Okay? What do we do now? Yeah, and get them over one denominator. So you're going to multiply these out. You're going to get x squared minus 2x minus 3 plus 6x plus 18 over x plus 3 squared times x minus 3. And if you get everything combined on the top, you have x squared plus 4x plus 15 over x plus 3 squared times x minus 3. So all addition all the time, when it's fraction plus fraction, life is good. You've got to be extremely careful when you get to the subtraction problems. And it just means you need to be paying attention. And it's the second numerator that you have to be careful with. So let me show you what I'm talking about here. This is 3x over x minus 5 on the left, minus 2 over, what will that become? Difference of 2 squares, x plus 5, x minus 5. Okay? So no different yet. Everything's good. What's the LCD going to be? Okay, so it stays x plus 5 and x minus 5, no power changes. Is everybody with me? I'm finding the LCD. What do you do to the fraction on the left to get the LCD? What do we do to this? Multiply by x plus 5, top and bottom. And again, this stuff in green up here, show it, don't show it, I don't care. That's going to give you 3x times x plus 5. What are we going to multiply this one by? Nothing. So that's going to stay 2. So this one's not going to be a big deal either. You're going to get 3x squared plus 15x minus 2 over x plus 5, x minus 5. And again, we still can't factor that numerator. Okay, so this subtraction didn't have the issue because we had a monomial factor when we got common denominators as the numerator. Let's see if this one will be any better. This one's going to happen. What do we do at the bottom left? Factor out of 3. I'm going to leave this 2x plus 2. How does the right factor? Excellent. X minus 5 and x plus 1.
Where are we in the top? Why are we getting this next?
In this case, it's worth factoring it out. Sometimes it is, sometimes it isn't. Why is it worth it here? Because you're going to have that you couldn't what? Why not? Yeah, but I haven't got common denominators yet. All I did was factor top and bottom. What this is going to do for you is make your denominator, common denominator, a smaller common denominator. Does that make sense? Just saving you time in the long run.
Only if you don't have your common denominator yet.
Yeah, but if you factor top, factor bottom, factor top, factor bottom, and you can reduce here, now when I go to my LCD, what's my LCD going to be? 3x minus 5. So this stays x. This becomes 3 times x minus 5. What do I have to do to get to 3x? Multiply by 3, top and bottom. So I have 6 over 3 times x minus 5. That's where you don't want to cross cancel, because then you'll be back to the line above. So we end up with x minus 6 over 3 times x minus 5. Again, still didn't accomplish what I want. We need a polynomial on the right-hand side, and we'll get there. Any questions on this one? So if you can reduce, go ahead and reduce. That's good. But you got to do it before you get the common denominator. Okay? So this is going to be 7 over 3 times x minus 3 minus x plus 4 over x plus 3, x minus 3. Personally, I can't leave it like that. I do this. So so that I remember I can't cross out an x or a 4. It's an x plus 4. It's already factored. We're good to go. What is my LCD going to be? And be careful on this one. Yeah, that didn't help. Thank you.
3 times x minus 3 times x plus 3.
3. I usually do the plus first just out of habit. Doesn't really matter which order you put them in. But don't forget the 3 as a constant has to be there as well. On the left-hand side, what do I need to multiply by to get the LCD? X plus 3, top and bottom. So that's going to give me 7 times x plus 3. Now, those of you, and I don't know if this will apply to what we were talking about before, Sar, you do not want to distribute or multiply what you get in these tops before you get them under 1 or over 1 denominator. So what am I going to multiply by here? 3 top and bottom, right? So we're going to have a 3 times x plus 4. Now I'm going to put an extra step in this one just so you can see what's going on. 7 times x plus 3 minus 3 times x plus 4 over your LCD. And again, I'm not saying you have to show this step. I'm just putting it here so that you can see. It's top minus top over the LCD. And here's where the issue comes. Because it's minus, and you have a monomial times a binomial coming up, when we try to simplify this top, 7x plus 21, what do we get next? Minus 3x minus 12 over, and right here, what have I called that over and over and over and over again this year?
Most commonly made mistake.
The most commonly made mistake in algebra. Failure to distribute correctly, and in particular, failure to distribute this negative for the second term of your binomial is so common and so easily missed that I've dubbed it the most commonly made mistake. Once you've done that, then you can go ahead and clean up the top. So we're going to get 4x plus 9 over 3 times x plus 3 times x minus 3. And again, we have no reducing that we can do there. Okay, so that's, I put extra steps in here. I'm not saying you can't do them. By all means, the more you show, the less likely you screw up. But I'm not telling you you have to have those steps. I'm just saying, look, this is where the mistake occurs. Be careful. And if you want to show more, show more. More is better in some cases. Any questions on this example? This is 6th grade concept applied to Algebra 2 level material. So the concept hasn't changed at all about getting the common denominator. It's the application with the variable expressions that makes this a nightmare. So see how you do with this one. Now you have 3 terms you're adding and subtracting. So we have 3 fractions, already all factored. You should be able to come up with your LCD. First thing that I usually do is parentheses around anything that's not a monomial. So your LCD has to have x's and x minus 2.
X squared.
X squared, because the power on this x is bigger than this x. So we have x squared, x minus 2, x squared, x minus 2. What are we going to multiply by the x in the first fraction? X and x minus 2 to get the LCD. So you're going to have 3x and x minus 2. What do we multiply the red denominator by?
X squared.
X squared. And the green denominator?
X minus 2.
X minus 2. So when we combine all of these, you're going to get 3x squared minus 6x plus 2x squared minus 2x plus 4 over the LCD. Most commonly made mistake is to have a minus 4 here. Okay? When you combine like terms, you're going to get 5x squared, 8x in the middle, and 4 at the end, over x squared times x minus 2. Can we factor the top? And it stays like this. Questions on this one? One more time. Fraction. What's different about this denominator in the LCD? So that's what I multiply by. X and x minus 2 on the top, and x and x minus 2 on the bottom. Doesn't matter. You talk about the order, or?
I was just, because like, the idea I wasn't sure if it was like, parentheses x minus x minus 2, or like, it was like 3x.
Riley wrote it like this: x times x minus 2 times 3. It does, the order in which you write them in this state right here does not matter. It's totally up to you. Anybody else on this one? Okay. The last one I want to show you, probably, is one where you have a constant or a monomial not in a fraction form, and then a fraction. When that happens, you want to treat that as over 1. And then continue with the same idea. This is not factorable. X squared minus 2 is not factorable. So my LCD is simply x squared minus 2. And we can't factor that x squared minus 2 because 2 is not a perfect square. So this is going to become 2 times x squared minus 2, and this just stays an x. So we have 2x squared minus 4 plus x over x squared minus 2. 2x squared plus x minus 4 over x squared minus 3. If you have a constant or a monomial term, put it over 1. And then carry on just like every other problem we've looked at. Tomorrow we're going to take the concept of multiplying and dividing fractions, along with adding and subtracting fractions, and we're going to put them together. And you're going to see problems that start to look like this, where you have a sum of 2 fractions on the top, a fraction in the denominator. These are complex fractions, and they're pretty hairy. Okay? But we're not going to, tonight you have, tonight you have just this part of the assignment, on the top, just through 24. Well, you're on the next couple of days. Here's some Friday. Okay. This second half of the stuff, I'll post a video and 7 notes tomorrow. So it'll take 8.5, algebra 3.5, video notes day 1 of today. Tomorrow after 3 o'clock, for day 2.5, video notes day 2. And then I'll post the entire 7 notes tomorrow after. There's 2 ways. Lucas, the second one, Lucas, is going to be find the LCD for everything that's there. Like every fraction function. So we'll talk about that. But hey, more coffee.
Oh, lighting was scary. I was happy I wasn't tall. Oh no, we're gonna go run like 7,200.
So when your mom your mom in all the time.
That's just okay.
Here's the thing, you're not doing it. I have 8 students doing what they're supposed to be doing. I can live with it, Dave. I can totally live with that. So you now have the ability to determine when to pay attention to and when not to. You're in a fantasy. You're in a fantasy. So I am required. You don't know what make it happen. So I've told you to someone prop that door open, please. Careful out there, it's nasty. How was it? Just okay? Which one is it? Oh, this was because we used the magic 8 ball in one of my classes.
Magic 8?
Yeah. Yeah.
Can you put in my place?
Can I what?
Put in my pillows.
What do you mean?
Huh?
I'm sure I already did.
And so my mom called me an idiot because I would be
Called you an idiot? Did you ever be in the class? Say, Mom, you took me to Thunder Valley for Thanksgiving. You shouldn't be saying things like that to me. You can use that for the rest of your life.
What if my dad gets with us so I can't use that?
Your mom has no control in your house? Wow.
Actually, yes.
I bet that's just not true.
So can you put it in?
I can, but I think I already did.
But it's not on Android.
When did you check?
Like 20 minutes ago.
Then I didn't put it in.
Then can you?
Of course I can. I've been doing grading for a long time. I can definitely put it in.
Can you do it right now? I think I found your hidden math symbol.
Really? Where is it?
Parabola. No, it's the scarf, it's a pie.
That's right.
Wait, where? No.
Yes.
Oh!
I'm so productive.
I thought it was the parabola.
No, that's what I thought too.
Those aren't parabolas.
No, they are.
No, they're not.
Yes, they are.
Why aren't
No, they're not.
Why?
Because when you hang a wire like that between 2 points, It does not generate a parabola.
What is it?
It's something called something other than a parabola, and I can't remember the name.
Is it a problem?
I can look it up for you, but I don't think you really care. So
No, I do.
We really care.
Yeah.
Still high school.
you want to know what it's called when you
Yeah.
hang?
So, are they for the homework?
Yes, but we're quizzing on Friday, right? So we're on the
Yes.
first 8.5 lesson, which was supposed to be yesterday.
So it takes more than one day?
What?
We have 2 days allocated for it. Yes. Yes.
No, it's like lotion. It's like the stuff you get at hotels. It's the cool kind.
Hi, Dana. Be careful out there.
What is this? Took his lotion?
Get me an integrated 3 book off the shelf over there. Not you, Ashley. He's going to do it.
Why?
Go over. If you walk over there and do as I tell you.
So
Do
I
not
can be a
question me.
servant, but she can?
Do not.
For the love of it, I'll get the book. What is it?
I'm not looking it up till Aditi gets it.
Or Mira.
You're right. I also don't have to look up your stuff for you either.
What stuff? Why do you want it? Oh.
Oh, nice.
Wait.
Gentlemen, both of you, we have an additional helper for you. So we're going to straighten desks. We're going to wipe desks down. And we're going to pick up all this crap off the floor. Anything that's too big, like pens and pen caps and such, needs to be picked up by hand. You're going to straighten desks going this way and this way
Yeah, I
off
kinda
of this
wanna
row. Right.
What am I don't want to walk in the rain. Why is everything? Ew! It's just a tea bag.
Right? And I'll grab some vacuum. And then while two people are vacuuming, someone else,
Hey, I have to work for
someone needs to
myself
do
on this one.
tabletops.
Your birthday.
Outside, you're doing what?
You can do it with me. You have to work on my birthday.
What do you do? Alright, you grab the vacuum.
I'm gonna sign up. Can you sign up more than one?
No. Otherwise, people would just sign up every day and get like.
I'm just gonna sign up for school stuff.
Ethan Robertson, please come to the assistant principal's office. Ethan Robertson, please come to the assistant principal's office.
I only have one vacuum. So two of you can do tabletops. So use these right here.
Alright.
You should be able to
He's gonna
do.
vacuum first because the chairs.
Yeah, you don't need to put the chair. You should be able to. I mean, you should be able to work around them. So you're defiant at home too?
I'm defiant.
When I tell you to do something, there's no why.
You can order me.
I most certainly can.
He's your guru.
Of course I can.
Nice to please.
It would be nice, but I don't. I'm just telling you what to do, woman. All right. Let's see. I'm sure it's in here.